Good morning to you all. My name is Anodi Young and I welcome you all back to the YouTube channel. And this is a single variable calculus lecture series. In the previous lecture, we talked about indeterminate limit forms. We solved some problems on limits. We didn't really go into details. We also talked about some standard limits. And today I want us to solve some problems or questions from the various universities. So we begin. So the first question. A limit, this is actually simple, so we begin with the easy ones and proceed with the difficult ones. So if you have cos x minus 1, sin x minus 1, find the limit of this expression as the independent variable x is approaching 0. How was it done? So as x is approaching 0, our expression becomes cos 0 minus 1 on sine 0 minus 1. What do we get? Cos 0 is 1, 1 minus 1. Sine 0 is 0. So we end up with 0. So our answer for this limit is 0. Now the next one, the limit as x is approaching 5 of the expression s squared minus 25 on x minus 5. Now, in the previous lecture, I told you that whenever you have a limit expression, and after you've done the direct substitution or apply the limit rules, you realize you are getting 0 over 0. What do? I gave you 3 things you do. Now you check if that is the numerator or the denominator contains a polynomial. You try as much as possible to factorize that particular polynomial either on the numerator or the denominator to cancel out some of the factors. Now, if your composite, that's the limit of the composite function, contains a what? A radical. What do? You try as much as possible to rationalize that particular radical to get rid of the what? Of the radical. Right? Then after you can apply the limit rules. And I also told you that when your limit, when the expression you are finding the limit of as some independent variable is approaching some value is made up of, that is a complex fraction either on the numerator or the denominator, what do? You simplify that particular complex fraction before you can apply the limit rules. Yes, so we first check if it's an indeterminate. So as x is approaching 5, what do we get? That's 5 squared minus 25 on 5 minus 5. We end up with 0 over 0, and this is clearly an indeterminate. So what do? Since that is the numerator is a polynomial, right? We can factorize the numerator. So the limit as x is approaching 5 of factorizing this can be written as difference of 2 squares. So we end up having x plus 5, x minus 5. Then we can cancel out some of the factors. So our final limit expression becomes x plus 5 as x is approaching 5, and as x approaches 5, our expression becomes 5 plus 5, which is equal to 10. This is so simple. Now we'll move on to the third problem. What is the third problem? Now, let's say you have the limit as x approaches 5 of, no, not 5, the limit as x is approaching 2 of x cubed minus 7x squared plus 10x all over x squared plus x minus 6. So as you realize, the numerator and the denominator are all polynomials. So what do we do then? We try as much as possible to factorize the expressions on both the numerator and the denominator. But first, you have to check if this is an indeterminate. So what do? As x is approaching 2, we end up with 2 cubed minus 7 times 2 squared plus 10 times 2 all over 2 squared plus 2 minus 6. what are we going to get? On the numerator, 2 cube is 8. Negative 7 times 4 is negative 28. So we get negative 20 plus positive 20, which is 0, over 4 squared plus 2 is 6, minus 6 gives you 0. So this is clearly an indeterminate. Now, since the numerator and the denominator both contain a polynomial, what do? We factorize to cancel out some of the factors. So for the numerator, we can first factorize out x, because x is a common factor in all the three terms. So x out, 10 squared, 10, x squared, not 10, x squared minus 7x plus 10, all on x squared plus x minus 6. Now we can factorize this. This is the result of two binomials, when two binomials are multiplying. So we can factorize. So now factorizing the first one, we can do it separately. For x squared minus 7x plus 10, what are we going to get? Now, when x squared is multiplied by 10, what do we get? 10x squared. Factors of 10x squared, when multiplied, will give you 10x squared, but when added, will give you negative 7x. And that will be negative 5x, negative 2x. So from here, we can do our factorization. So x out, x minus 5, negative 2 out, x minus 5. We end up with x minus 5, x minus 2, x minus 2, x minus 5. Then we can substitute in the expression. That is wherever we see x squared minus 7x plus 10, it is x minus 2 in parentheses, multiplying x minus 5 in parentheses. Let us also factorize this. Now, when x squared is multiplied by negative 6, let's find factors of negative 6x squared. When multiplied, will give you negative 6x squared, but then when added, will give you positive x. And those factors will be 3x minus 2x. So x squared plus 3x minus 2x minus x. So from here, what do we get? We end up with x out, x plus 3, negative 2 out, x plus 3. So the factors become x minus 2x plus 3. That's so simple. So we substitute in these into the limit. So let's continue. So now the limit as x approaching 2 of x bracket open, that is x minus 2, x minus 5, all over x minus 2, x plus 3. Now, x minus 2 cancels x minus 2. So we end up with the limit as x is approaching 2 of x multiplying x minus 5 on x plus 3. So here the job is simple. The limit as x is approaching 2 of the expression. So that is, as x approaches 2, what would this limit be? As x approaches 2, we'll get 2 multiplying 2 minus 5 on 2 plus 3. We end up with 2 minus 5 is negative 3 times 2, negative 6 on 5. As simple as that. I believe this is a simple problem. We move on to the next one. Let us step it up a little bit. Okay, before we step it up a little bit, let's try to solve this. The limit as x is approaching 0 of x cubed minus 1 all on x minus 1. So yes, we check if it's an indeterminate. So doing our direct substitution or applying the limit rule. As x is approaching 0, what do we get? 0 cubed. No, it's not supposed to be as x approaching 0. It's supposed to be as x approaching 1. So as x is approaching 1, we get 1 cube minus 1 on 1 minus 1. We end up with 0 over 0. And this is clearly an indeterminate. So what then do we do? Now you realize our numerator contains a polynomial and it can be factorized. So we factorize it to see if we are going to come out with factors that would cancel out, right, in the denominator. So how do we factorize x cubed minus 1? Now you remember from algebra, the difference of two cubes can be written as a minus b multiplying a squared plus ab plus b squared. You remember this? I can actually prove this, but I don't know if it's really necessary. I don't think it's necessary. I strongly believe most of you remember this because we were really using this expression in algebra way back in high school. So yes, so meaning x cubed can be written as, x cubed minus 1 can be written as difference of two cubes. So end up with x minus 1 multiplying s squared plus x because x times 1. So get x plus 1 squared, which is 1. So the factors of s cubed minus 1 cube are x minus 1 multiplying s squared plus 1. Sorry, s squared plus x plus 1. That will substitute in this into this. So the limit as x is approaching 1, x minus 1, s squared plus x plus 1, all on x minus 1. This cancels out this. We end up with the limit as x is approaching 1 of the expression s squared plus x plus 1. So as x is approaching 1, what do we get? We get 1 squared plus 1 plus 1. Our answer is 3. This is also quite simple. Now, let us step it up a little bit. Let's just say we are moving out gradually. This particular question may not seem very difficult to some of you, but then I'm trying as much as possible to feed every single student. So if you have the limit of these two expressions, now we do our direct substitution. So our direct substitution as x is approaching 1, what do we get? We get 1 over what? 0 minus 2 over what? 0. So I realize we are getting an infinite value minus an infinite value, right? Infinity minus infinity, we can't really specify. So when you have such a condition, that is after applying the limit rule, because we can apply the limit rule here. That's the difference rule. The limit of this expression minus the limit of this expression, but then we still aren't going to get the answer. If you have such a condition, that is a condition where the limit rules are not applicable. I talked about this in the previous lecture. The limit rules are not applicable. What do? You simplify or evaluate the expression in the parentheses. So we can do that. So it becomes the limit as x is approaching 1 of the expression. Simplifying, first get the LCM, which is s squared minus 1, because s squared minus 1 can be factorized as x minus 1 in parentheses, x plus 1 in parentheses. This. So the factors of s squared minus 1 are these. So you realize that x minus 1 is also a what? A factor. So the LCM is s squared minus 1. So x minus 1 divides s squared minus 1 how many times? X plus 1 times. Then you multiply the resultant, the resultant factor by 1. which is x plus 1. Now, x squared minus 1 divides x squared minus 1 how many times? That is 1 time. So 1 multiplied by 2. This is what we end up with. So, what will be our answer now? We are going to end up with, that is, the numerator will be x minus 1. The denominator will be x squared minus 1. So from here, it is simple. I can write the denominator as a difference of two squares. So x plus 1, x minus 1. Now this cancels this. I end up with a limit as x is approaching 1 of 1 over x plus 1. Then from here, you can do your direct substitution. So from here, as x is approaching 1, we end up with 1 over 1 plus 1. And our answer is half. And I believe this is also simple. I believe this is also simple. We move on to the next problem. Let me step it up a little bit. Now, say you have, that is, the limit as x is approaching 0 of the expression root of x plus 3 minus root 3 all over x. Now, so here you realize we have, that is, a radical on the numerator. But you first, let's check whether the limit of this expression gives us an indeterminate. So doing our direct substitution, as x is approaching 0, we get root of 0 plus 3 minus root 3 all on 0. We end up with 0 over 0, and this is clearly an indeterminate. So what do we do? Then, since our numerator contains a radical, we do what? We try as much as possible to eliminate the what? The radical. Right? The radical containing, that is, the independent variable. Yes. So we rationalize. So I multiply the numerator and the denominator by the conjugate pair of this. So multiplying root of x plus 3 plus root 3 all on x, multiplying root of x plus 3 plus root 3. And here the job is done. Now, the numerator is basically the what? That is the difference of two squares, right? This, when multiplied together, will result in the difference of two squares. So root of x plus 3 all squared minus root 3 all squared all over x multiplying root of x plus 3 plus root 3. What do we get? We end up getting the limit as x is approaching 0 of, that is, x plus 3 minus 3 all on x multiplying root of x plus 3 plus root 3. Strongly believe this is simple. This is simple. So the limit as x is approaching 0. So the numerator gives us x. The denominator gives us x multiplying root of x plus 3 plus root 3. So you realize the x cancels out the x. We end up with the limit as x is approaching 0 of 1 over root x plus 3 plus root 3. And this gives us 1 over, that is, 2 root 3. It is so simple. This is so simple. Yeah. Now, there is also another way to also get rid of the what? Of the square root. I'm chipping in this method because it will actually come in handy. Right? Now, under the radical expression, see, under the radical, so our problem was limit as x is approaching 0 of root of x plus 3 minus root 3 all on x. So we want to eliminate this, right? Because this particular radical contains our independent variable. And we want to eliminate this particular radical. Then I can substitute in some particular variable. So I can say a squared is equal to x plus 3. So that when a squared is substituted here, the square root will do what will go away. But then as a squared is equal to x plus 3, then our limit will change. So as x is approaching 0, what will my a be? My a will approach root of 3. Will actually be plus or minus root of 3, but we use the positive root, right? We use the positive root. So it becomes limit as x is approaching root 3 of this becomes square root of a squared minus root 3 all on what will x be? X will be, that is a squared minus 3. So simple. So here the numerator becomes with 3, that is a squared under the square root gives you a minus with 3 all on a squared minus 3. So here we can do our factorization. This, the a squared minus with 3 can be written as difference of 2 squared, that is a squared minus with 3 all squared, and we end up with a plus with 3, a minus with 3. So what do we get to end up with? Limit as x is approaching root 3 of a minus root 3 over a plus root 3 multiply a minus root 3. This cancels this. We get 1 over a plus root 3, which is equal to 1 over root 3 plus root 3, and we end up with 1 over 2 root 3. Right? This is also a simple method. It will actually come in handy. That is when you miss certain problems. So you miss certain problems, it becomes very difficult to rationalize, right? But then if you know your algebra so well, those problems wouldn't be any problem to you. Those problems wouldn't be any problem to you. Now let us try another problem like that. So let's say you have the limit as x approaches 0 of x multiplying the expression 1 minus x on 1 minus root 1 minus x. So for here, we can also do our rationalization, but then first we need to check whether this gives us an indeterminate. So as x is approaching 0, we get 0, 1 minus 0. The numerator becomes 0, 1 minus, that is square root of 1 minus 0. We end up with 0 over 0. So this is clearly an indeterminate. Then what do? We have a polynomial on the numerator, and then we have a what? We have, that is a radical on the denominator, right? Or a set on the denominator. And we try as much as possible to eliminate the set, because for the polynomial it has already been factorized. So our main issue is to eliminate the set or to eliminate the radical. What do? I can use any of the method, that is rationalization. So let us rationalize first. Rationalizing the denominator, 1 minus root 1 minus x multiply by its conjugate pair. What do we get? That is 1 plus root 1 minus x divided by 1 plus root 1 minus x. This becomes what? This becomes x multiplying the expression 1 minus x, that is times 1 plus root 1 minus x all over. This can be written as the product of two squares. So 1 squared minus, that is root 1 minus x all squared. So this becomes x multiplying 1 minus x, 1 plus root 1 minus x. Now the denominator becomes 1 minus x plus sorry, 1 minus 1 plus x. That is the limit of this expression as x is approaching 0. Then our denominator becomes x. So we can cancel out, that is the x on the numerator and the x on the denominator. So x, so this cancels out this. We end up with 1 minus x multiplying 1 plus root of 1 minus x. So as x is approaching 0, what do we get? As x is approaching 0, we end up with, as x is approaching 0, what do we get? As x is approaching 0, what do we get? Oh, I think I've made a mistake somewhere. I'm coming. I think I've made a mistake somewhere. Let me check. So from here, 1 squared minus, okay, all right, okay, okay, okay. We made a mistake. Yeah, so here becomes, that is x multiplying 1 minus x in parentheses multiplying 1 plus root of the expression 1 minus x, all divided by 1 squared minus, that is 1 plus x. Yeah. Then what are we going to get? As I said, the limit as x is approaching 0, you realize that there will be x on the denominator, so x cancels. We end up with 1 minus 1 multiply 1 plus root 1 minus 1. So what do we get? You realize when you substitute in 0 here, what are we going to get? We end up with 1 multiplying. Actually, we didn't make a mistake. I don't think we made a mistake. So our answer becomes 2. So our answer is 2. Now, we can also use the method I brought in, right? Our question was the limit as x is approaching 0 of the expression that is x multiplying 1 minus x all over 1 minus root 1 minus x. So here I want to eliminate the what? That is the square root or the radical. Then I can say that let a squared be 1 minus x. And if a squared is 1 minus x, then our limit will change. So as x is approaching 0, that is our a would be what? Our a would approach 1. It will be plus or minus 1, but as I said, we consider the what? The positive limit, right? So limit as a is approaching 1 of, now what will x be? X will be, that is 1 minus a squared. So 1 minus a squared will be our x. 1 minus x is a squared divided by 1 minus, that is root 1 minus a, which is what? A squared. So a squared under the root will give us 1 minus a. So simple. Now from here, you realize we can, that is factorize 1 minus a squared, which will give us 1 minus a multiplying 1 plus a in parentheses. So 1 minus a cancels out 1 minus a. What then do we get? We end up with, that is the limit as x is approaching 1 of 1 plus a multiplying a squared. Then as x approaches, sorry, not x, it's a. As a approaches 1, what do we get? We end up with 1 plus 1 multiplying 1, which is 2, the same thing. I think this was actually faster than the other one. This was actually faster than the other one. Now, let's move on to the next question. Let's move on to the next question. Now, let's just say you have, that is the limit as x approaches 0 of the cube root of the expression 8 plus x minus 2 all on x. Here first, I'll use the second method I taught you, but let's check whether it's an indeterminate. So as x is approaching 0, what do we get? The cube root of, that is 8 plus 0 minus 2 on 0. Cube root of 8 is 2, 2 minus 2 is 0, 0 over 0. So this is clearly an indeterminate. Now, if you have an indeterminate and our numerator or denominator contains a radical, what do? We try as much as possible to rationalize, right? I'll talk about the rationalization second, but then let us use the second method I said. So in order to eradicate the radical, right? What variable, what selected assumed variable should I put, or should I substitute in for 8 plus x? And that can be, let's say, y cube or a cube. So a cube is equal to 8 plus x, right? So when a cube is substituted in here, you realize that cube cancels the cube root. So if a cube is equal to 8 plus x, then our limit also changes. So as x is approaching 0, what would our a? As x approaching 0, our a will be, that is 2, the cube root of what? 8. So now our new limit becomes limit as a approaches 2 of the expression, that is a minus 2. Because yes, if a cube is put under the radical, we get what? What do we get? We get, that is a. So a minus 2 divided by x. What is x? X is a cube minus 8. So simple. So you realize that for the denominator, we can factorize it because it can be written as difference of for 2 cubes. And we know x cube minus y cube, right? I should use a different variable. Let's say you have c cube minus b cube. Can be written as c minus b in parentheses, c squared plus cb plus b squared. Remember this. So meaning for the a cube minus 8 can be written as a cube minus 2 cube, which is equal to a minus 2 a squared plus a times 2, which is 2a plus, that is b squared. So our b is what? 2, which is 2 squared, which gives us 4. So wherever you see this, we substitute in this expression. It is not difficult at all. So the limit as a approaches 2 of, that is a minus 2 on a minus 2 in parentheses multiplying a squared 2a plus 4. This cancels this. We end up with a limit as x is approaching 2 of 1 over a squared plus 2a plus 4. What do we get? So as x is approaching 2, we end up with 1 over 2 squared plus 2a plus 4. So our answer is 1 over 12. Now, let us also try to rationalize our radical, right? So the method, this method 2. Should I say, no, this is actually the first method we've been using, right? Which is the rationalization method. So let me just say method, okay, let me say method 2. So method 2, using the rationalization method, our limit expression was cube root of 8 plus x minus 2 on x. Now, To rationalize means to try as much as possible to eradicate or eliminate the said, right? Or the radical. What then do? We need to multiply the numerator by some expression to get rid of the what? Of the root. And as I said earlier, let's say if you have a cube minus b cube can be written as, that's where the difference of two cubes can be written as a minus b, a squared plus ab plus b squared. We are going to use the same idea. That is, if the first term here, if the first term, which is the cube root of 8 plus x, is cubed, you realize we are going to eliminate the what? The cube, right? Minus, so that's what we'll do. So we'll say, let our a be equal to what? Cube root. And cube root can be written as 8x raised to the power 1 over 3. And let our b be 2. So 8 plus x all raised to the power 1 over 3. That is cubed. Cubed minus 2 cube is equal to what? Gives us that is a minus b. Our a is 8 plus x all raised to the power 1 over 3. So 8 plus x all raised to the power 1 over 3 minus b. Our b is what? 2 in parentheses, multiplying a squared. What is a squared? So it can be written as 8 plus x raised to the power 1 over 3 squared. So it becomes 2 over 3. Becomes 2 over 3. Plus ab. What is a? 8 plus x raised to the power 1 over 3. B is 2. So we have 2 multiplying 8 plus x raised to the power 1 over 3. Plus b squared. B squared is 4 because b is what? 2. So we need to multiply the numerator, and this is the numerator, by this expression in order to eradicate the what? That is the said. So let's do that. So our expression becomes a limit as x is approaching 0 of, that is 8 plus x raised to the power 1 over 3 minus 2. Please pay attention. Minus 2 multiplied by this expression, this whole expression. So 8 plus x 2 on 3 plus 2, 8 plus x 1 on 3 plus 4. Do same to the numerator, the denominator as well. What was the denominator? The denominator was x. So x multiplying 8 plus x raised to the power 2 over 3 plus 2 multiplying 8 plus x raised to the power 1 over 3 plus 4. What do we end up with? What do we end up with? As I said, the product of these two will give us the difference of what? The two cubes. So we end up with the limit as x is approaching 0 of, that is cube root of 8 plus x all raised to the power 3 minus 2 cube divided by, that is x multiplying 8 plus x raised to the power 2 over 3 plus 2 multiplying 8 plus x raised to the power 1 over 3 plus 4. What do we get from here? Our numerator will become, the cube takes away the cube root. We end up with 8 plus x minus 8. So the minus 8 will cancel out the positive 8. So we end up with x on the numerator. X multiplying 8 plus x raised to the power 2 over 3 plus 2 times 8 plus x raised to the power 1 over 3 plus 4. So the x cancels out the x here. So we end up with the limit as x is approaching 0 of 1 all on 8 plus x raised to the power 2 over 3 plus 2, 8 plus x raised to the power 1 over 3 plus 4. So what do we get now? So as x is approaching 0, we end up with 1 over, that is 8 plus 0 raised to the power 2 on 3 plus 2 times 8 plus 0 raised to the power 1 over 3 plus 4. So now our answer is now 1 over this numerical value can be written as, that is 8 raised to the power 2 on 3, which is the same as find the cube root of 8, which is 2, then square it, which is 4, plus the cube root of 8 is what? 2 multiplied by 2, 4, plus 4. So end up with 1 over 12. We are getting the same answer. And I realized the other method is faster. That's the reason why I introduced that method to you guys. We move on. We proceed. Now let us solve this question as well. So the limit as x is approaching 5 of x cubed minus 7x squared plus 10x. Oh, sorry. The question is 4 minus root of 3x plus 1 all over x squared minus 7x plus 10. So from here, you realize that the numerator contains a radical, the denominator contains a polynomial. So we can do any of them first. We can either rationalize our numerator, then after we factorize the denominator to cancel out some of the factors. So here, let us factorize this. So x squared minus 7x gives us what? X squared minus, let's do it somewhere, then after we substitute it inside. So here, x squared multiplied by 10, that's the factors of 10x. When multiplied gives you 10x. Sorry, the factors of 10x squared. When multiplied gives you 10x squared, but then when added will give you negative 7x. And those factors will be, that is negative 5x, negative 2x. So here we end up with x out, x minus 5, negative 2 out, x minus 5. X minus 2 multiplying x minus 5. So these are the factors of x squared minus 7x plus 10. So let's do that. So limit as x is approaching 5, 4 minus root 3x plus 1 all over x minus 2, x minus 5. After we are done with this, we can rationalize the numerator. So multiplying both the numerator and denominator by the conjugate pair of the set. What do we get? The numerator is basically the what? That is the product. Finding the product of these two expressions gives you the difference of two squares. Can be written as 4 squared minus root of 3x plus 1 all squared divided by x minus 2, x minus 5, multiplying 4 plus root 3x plus 1. Now, what do we do then? We can simplify the numerator. What do we get? We get 16 minus 3x minus 1. That's the limit as x approaching 5. X minus 2, x minus 5, 4 plus with 3x plus 1. So what do we get for the numerator? The limit as x is approaching 5 of 15 minus 3x divided by x minus 2, x minus 5 multiplying 4 plus with 3x plus 1. What are we getting for this? Here we can factorize the numerator. We can factorize negative 3 out. to get x minus 5 divided by x minus 2, x minus 5, 4 plus root 3x plus 1. That the limit as x is approaching 5. So from here, we can cancel out some of the factors. So x minus 5 cancels out x minus 5. We end up with a limit as x approaches 5 of negative 3 divided by x minus 2 multiplying 4 plus root 3x plus 1 in parentheses. So here, as x is approaching 5, what do we get? We end up with negative 3. This becomes 3 multiplying mean 3 times 5 is 15 plus 1, 16. Root of 16 is 4, which is 8. So end up with negative 1 over 8. This is so simple. Now for this one, you can also use the substitution method I taught you. It is actually not difficult, but then I won't go through that. You can try it on your own. Now let us try some other problems. Say you have the limit as x approaches 1 of x minus 1 multiplying 2 minus x under the root divided by x squared minus 1. So here, let us try to factorize and see if. But then we first have to check. See, all the time you check, you do direct substitution first somewhere, probably on your rough paper, to check if the limit of the expression given is an indeterminate. If it's an indeterminate, that is where you try to apply the various techniques to solve the indeterminate limit expression. So here, as x is approaching 1, we end up with 1 minus 1 multiplying 2 minus 1 divided by 1 squared minus 1. We end up with 0 over 0. So this is clearly an indeterminate. So what do we do? We have x minus 1 here, but then x squared minus 1 also has factors containing x minus 1. So we can factorize the denominator to get x plus 1 in parentheses, x minus 1 in parentheses. So this cancels out this. We end up with limit as x is approaching 1 of 2 minus x under the square root divided by x plus 1. So as x is approaching 1, what do we get? We get root of 2 minus 1 divided by 1 plus 1. And our answer is what? That the square root of 1 is 1. Our answer is half. Half. This is simple. I believe this is simple. Now, we've solved a lot of questions. Let us solve some more. To get more concept. Now, the limit as x approaching 4 of 2 raised to the power x cubed minus 5 divided by 3x plus 2. So for here, do a direct substitution as x is approaching 4. What do we get? We end up getting 2 multiplying 4 cubed minus 5 on 3 times 4 plus 2. What is 4 cubed? 4 cubed, 4 times 4, 16. 16 times 4, 64. 2 times 64, 128. 128 minus 5, 123. 3 times 4 is 12. That is 12 plus 2 is 14. So the answer is 123 divided by 14. This is actually not difficult. It is not difficult. This is not difficult. Shall we proceed? Let us move on. Now let's just say you have the limit as x is approaching, say, infinity, of 2n minus 1 divided by 3n plus 1. You realize when we're talking about the limit to infinity, what did we say you do? You divide through by the highest power of what? Highest power of, that is the independent variable. The highest power of the independent variable here is 1. So you divide through by what? That is 2n divided by n minus 1 over n divided by 3n divided by n plus 1 over n. What do we get? We end up with the limit at x is approaching infinity of 2 minus 1 over n divided by 3 plus 1 over n. So applying the limit rules. Now, as x is approaching infinity, you realize 1 over n will approach what? Will approach 0, because if you have 1 over a large value, mathematically you can write it like this, but then to get the idea, if you have 1 over a large value, that value approaches what? 0. It approaches 0. So our limit becomes 2 minus 0 divided by 3 plus 0. And we get 2 over 3. But then you realize I showed you some properties of these, right? That is, if you have the limit to infinity of a composite, right, such that that is the highest power on the numerator and the same as the highest power on the denominator, then what will be the limit? What will be the value for the limit? The value for the limit will just be the what? The coefficient of, that is the greatest, the coefficient of the term with the greatest power of the independent variable divided by the coefficient of the term, the greatest power of the independent variable on the denominator. As simple as that. That's the reason why we are having 2 on 3. Right? This is actually simple. Now, let us move on to another one. Let's just say have the limit as n is approaching infinity of the expression x plus 5, that is not nx squared divided by 2x squared plus 3x. So here I can boldly say the answer is 5 over 2. So divide through by the greatest power of what? Of x. True. So x divided by, x squared here. 5x squared divided by, that is x squared. All on 2x squared divided by x squared plus 3x divided by, that is x squared. We end up with the limit as x is approaching infinity of 1 over x plus 5 divided by 2 plus 3 over x. So realize as x is approaching infinity, that is our 1 over x would approach 0, and also our 3 over x also approach 0. So our limit becomes, that is 5 over 2. As simple. If you want me to write it as 5 plus 0 over 2 plus 0, which is 5 over 2. I believe this is quite understandable. There's also another method for solving, that is the limit as an independent variable is approaching, that is infinity, right? That is whenever you have, so let me use this as an example. 2n minus 1 divided by 3n plus 1. I can convert this to, that's the limit approaching 0, by doing what? By saying n is equal to 1 over x. Right? So all the time, wherever I see n, I substitute in 1 over what? 1 over x. But then as n is equal to 1 over x, then as n approaches infinity, our x becomes, so as n approaches infinity, our x approaches 0. So our new limit becomes limit as x is approaching 0 of 2 divided by x minus 1 divided by, that is 3 on x plus 1. So from here we simplify. So simplifying, we get 2 minus x over x divided by 3 plus x over what? Over x. We end up with limit as x is approaching 0 of 2 minus x divided by 3 plus x. So from here, you can just substitute in your 0. So as x is approaching 0, our expression becomes 2 minus 0 divided by 3 plus 0. We end up with 2 over 3. As simple as that. So you realize it is actually simple. It is so simple. It is so simple. Now let us try one which is a bit technical. One which is a bit technical. So let's say you have, that is the limit as x is approaching infinity of square root of 3x squared plus 2 all over x minus 2. Then I can say that as x is approaching infinity, then let x be equal to, say, 1 over y. So wherever I see x, I substitute in 1 over what? 1 over y. So here I'll have limit as y. But mind you, as x is approaching infinity, our y would approach 0 because our y will be equal to 1 over x. So when you put in infinity in place of x, you get 0. The limit as y is approaching 0. We'll have, that is 3 over y squared plus 2 all over, that is 1 over y squared, 1 over y minus 2. So we end up with 3 plus 2y squared divided by y squared all over, that is 1 minus 2y divided by y. So from here, we can simplify. You realize for this particular expression, for the numerator expression, we can find the square root of y squared. I mean 1 over y squared. What I'm going to get? 1 over y. So 1 over y limit of 3 plus 2y squared. Sorry. I want to write it like this. 1 over y multiplying root 3 plus 2y squared all over 1 minus 2y divided by what? Y. Now, some terms can cancel out. That is, the 1 over y here can cancel the 1 over y also here. So let me write it properly. I can also factorize 1 over y in the what? In the denominator. So 1 over y multiplying 1 minus 2y. So this cancels this. Then what do we get? We end up with the limit as x is approaching 0 of, sorry, not x, y. It's approaching 0. So I've been using x all this while. Okay. Yes, so as y is approaching 0 of the expression square root of 3 plus 2y squared divided by 1 minus 2y. What are we going to get? We end up with what? We end up with, that is, as y approaches 0, 3 plus 0 divided by 1 minus 0. So our answer becomes root 3. Our answer becomes root 3. Now you can also do it directly, right? That is by dividing through by the greatest power, but then you have to be very careful. You have to be very, very careful. So let us do that. The limit as x is approaching infinity of the expression square root of 3x squared plus 2 divided by x minus 2. So from here, there's one thing I can do. I can factorize x squared from the set here. So limit as x is approaching infinity, factorizing the x squared, I end up with 3 plus 2 over x squared. Here also I'll factorize out x. I end up with, that is 1 minus 2 over x. You realize we have square root of what? X squared. The square root of x squared. The square root of x squared here will be the absolute of what? The absolute of x. The square root of x squared will be the absolute of what? X. So here will be limit as x is approaching infinity of the absolute of x multiplying 3 plus 2 on x squared divided by x multiply 1 minus 2 on x. But then since our limit approaches positive infinity, then our absolute of x can be taken as positive x. Our absolute of x can be taken as positive x. So we end up with limit as x is approaching infinity of x multiplying 3 plus 2 on x squared divided by x minus 2 on x. This cancels this. So realize as x is approaching infinity, what do we get? 2 over x squared will become 0. As x approaches infinity, 2 over, that is infinity, approaches 0. And also 2 over infinity also approaches 0, which is the 2 over x. This is infinity squared. Let me write infinity squared here. Yes, this is 4. The 2 over x squared, and this is 4. The 2 over x. They all approach 0. What are we going to get then? We end up getting, that is 3 plus 0. Oh, sorry. I forgot the square root sign. So here, we'll get square root here. Square root here. Square root here. Yes, so as these approach 0, we end up with, that is the square root of 3 plus 0 divided by 1 minus 0. Our answer becomes root 3. So I believe both methods are fine with us. I want us to solve some 2 problems, 1 or 2 problems, then we call it a day. I don't want this particular video to be a long video. So let us also consider this. Now, let's consider this. Now, let's just say you have the limit as, say, n approaches infinity of n squared divided by 1 plus 2 plus 3 plus 4 plus to the last, that is term, which is n, right? To the last term, which is n. Now, how do we solve this? You realize the numerator has a polynomial, so we have to try as much as possible to do what? To factorize and then cancel out some of the terms. But then clearly you cannot cancel out directly by looking at this like this. So we do one thing. Now, what do we do? What do we do? I can convert the denominator expression to a normal algebraic expression, right? You remember from series and sequence way back in high school, that is the sum of some sequence, right? Of the individual terms of some sequence will be what? It is n over 2, which is the number of terms, multiplying 2 times a, where a is the first term, plus n minus 1 multiplied by d, where d is the common difference. So n number of terms, d common difference, and a first term. So then I can say that the sum will be what? The number of terms is n divided by 2. What is the first term? The first term is 1. N minus 1. What is the common difference? You realize the common difference between the individual terms is 1. The common difference is 1. So our Sn expression, that is the sum, will be what? The sum will be n minus 2 multiplying 2 plus n minus 1. So negative 1 plus 2 gives you 1. So I end up with n plus 1. So this is the expression n multiplying n plus 1 all divided by 2. You've actually seen this somewhere. You've seen this somewhere. So you can substitute this into the limit expression. So we end up with the limit of n squared divided by n multiplying n plus 1. That is, I can divide it by 2, so the 2 can come and multiply the numerator expression as n is approaching infinity. So from here, you can divide through by the highest power, but then let us evaluate further. 2n squared divided by n squared plus n. So dividing through by the greatest power, what do we have? The limit as n approaches infinity of 2n squared divided by n squared, all on n squared divided by n squared plus n divided by n squared. What do we get? We end up with the limit as n approaches infinity of 2 divided by, that is 1 plus 1 minus n. So as n is approaching infinity, that is our 1 over n would approach 0. So what do we get? We end up with 2 over 1 plus 0 is equal to 2. So this is our answer. Our answer is 2. Okay, so we end the video here. I'll come back with more problems. We'll end the video here, but then I will prepare a special lecture on one-sided limit, but not now. We'll probably talk about differentiation integration. Before that, is along the way, I may prepare some lectures on one-sided limit, because I've realized most of the universities here don't really talk about one-sided limit, but I will talk about it, right, for the sake of those from the other countries and some other places. Okay, so I'll end the lectures here. My name is Arnold Young, and this has been Smart Modium. Please try as much as possible to subscribe, share the link to your friends so that they may also do what, enjoy the lectures. And then I may leave in the description box the WhatsApp link to our WhatsApp community to also join. If you have any suggestions, if you have any problems, if you have any solutions, right, you can share your solutions there. Thank you very much. Have a wonderful morning.